Alright, so this is my final project. I chose to do a Kaggle competition. It's the Titanic competition. So basically the goal is to predict whether passengers survived the Titanic sinking. Um, so you're given two CSVs with the data. The training data basically has all of the columns here. So that's these below. The test data doesn't have the target, which is the survived. So that's whether or not someone survived the Titanic sinking. You're not given that on the test one. So the goal is to predict um, using a machine learning model and submit that. I also will, so I'll use that score and then also try to evaluate the models down below. But getting into the data, we're given whether or not they survived. This PC class is basically the class of ticket, so first class is nicer, and then there's second and third. You're given their name, their sex, age. This is a sibling spouse, so this is how many siblings or spouses the passenger had, and then you're given the parent and children. So that's how many parents or children someone had who was also on the vessel. Then you're given tickets, how much they paid for the ticket, and then for some people you're given the cabin, and then the embarked is just there were three places where they picked people up, so this is just where you boarded the ship, basically. So we can take a look here. We see that there's some missing values. Most of them are non-null, so it makes it a little bit easier, but we'll have to fill in a couple things. We can go down this, and this is for the test data. So again, there's a few missing entries, but we can fill those in. This is just a summary again of all of the features. So we'll start out by filling in null values. So there's only two missing values for embarked, so this is where they got on the ship. So I figured I could just try to manually impute them since there's only two. The first person, it looked like they had more of a French name. I think I looked up this last name. And then Emily. So I assigned them with the destination that was in France, Cherbourg. I don't know how you're supposed to say that. And then the second person, they're Miss George Nelson. So the other two destinations were in Southampton, that was in England, and then this last one was in Ireland. And since I couldn't really tell by their name, I just put them in Southampton since most people got on there. So that's just me writing these here. For fare, there's only one missing value for fare, so I'm just going to use the mean to put that in. For cabin, it's not really, I think, reasonable to fill in because we're missing the vast majority of entries do not have a cabin. So I instead put a value unknown if it's NaN basically. And then from there I try to extract just the letter. So if you look at the cabin again, there's like a letter that could be A through G, and then there's a number. So I'm basically just getting rid of the number and finding the letter. So we're doing that there. And just mapping that to the cabin column. For the name, I'm going to try to extract a title. So are many titles if you look through the list, but I tried to put everyone into one of the four most popular ones, which were Mrs., Mr., miss and master. Basically, Mrs. and Miss are just for a female who's married or unmarried, and Mr. Is for most men, but Master is for young boys. So basically, I just looked at the sex of a person. Well, first of all, I saw if they had one of these titles, and if they didn't have a title, there were a few different titles like captain, colonel, etc. So all of those people, I put them into one of these bins based on their sex and their age. And then from there, I will use the title to impute the age. So if the person has a missing value for age, then I will just take the mean of whatever the mean for their title is and put that in. So I'm doing that there. You can see all the mean ages here. Mrs. was 35, Master is the youngest, 4.5. So that's what I'm doing here. Lastly, so this is creating another feature. It's family size. So this is just adding the sibling spouses and the parent-child together. Just adding those up. So you have like an interaction term. For fair, it's highly skewed. There's like a few entries up here. It's hard to see, but so I took the log there. I wasn't sure what models I was going to use, so I just wanted to map this and make it so that you could play with more models. Lastly, I'm encoding features. So for embarked and cabin, I'm just using one hot encoding, so you can see that those are broken up here. Embarked S, so this is a 1, the other two are zeros. I didn't end up using title, which I can talk about below. And then also I'm encoding sex into 0 or 1 so that it can be put into a model. And from there, anything that's not numeric basically gets dropped. I dropped passenger ID too because it doesn't really give you any useful information. But I dropped name. I dropped the ticket because it seemed like it would be difficult to get any information out of. Most of them are just numbers. Some of them do have letters as well, but it seemed like it would be really hard to work with, and I couldn't really figure out what information to even try to extract, so I just dropped the ticket. And then I did end up dropping this title, which I can talk about when we get farther down. So here I'm creating training data X and Y and the labels. I'm just using the train data set that we're given, and then I'm also creating the input for the submission, which will be last, but we're not training on any of this data because we don't have the target label. So that's what this is everything that we're going to put into the models. I chose to compare 5 different models. So I have the gradient boost, logistic regression, random forest, KNN, and SVM. I also later did kind of a model where I ensembled these together, but I'm just going to start by comparing these. I did grid searches to try to figure out some of the parameters, if there were hyperparameters, like, yeah, so I just have a few here for random forest, the gradient boost, and then the SVM. And here I'm just training or fitting models on all of the trained data. And then also I'm calculating a cross-validation score for the model with 10 folds. So we can go look down here, and this is the model and the cross-validation score. So the gradient boost and the random forest seem to come out on top. The SVM also did pretty well. The KNN did the worst. Not really sure how I could make this any better, but I tried changing K for that and messing around a little bit with the features, but it pretty much always was performing worse than the other ones. So here I evaluated the top scoring model, which was gradient boost. So just you can see all the metrics here. I did an accuracy score, the F1 score, and then the area under the curve, and then I made a confusion matrix and then plotted this. I did, to do this, I actually did a split on the training data because I don't have any labels for the test data that they gave us, so I did an internal split, and that's what this X test and Y test are. And then I actually refit the model on the training data that I internally split. So this model technically is a little bit different than the one that's above, but it's kind of what I can work with. It's kind of weird to not have all the labels, I guess. So it is what it is. And then lastly, I did this ensemble. So basically, I got rid of KNN, but I kept all the other ones, and they basically each get a vote of 1, and that has this cross-validation score, which is actually worse than the gradient boost, and I think also the random forest, but I did submit it. So if we go to the final results, I submitted the ensemble model and then the random forest and gradient boost. And actually, the gradient boost did worse out of these three. It got 74.88%, and the voting one actually did the best. It got 79.18. So I think overall the scores are pretty decent from what I can tell. I think some people are getting over 80%, so maybe I could try to tweak a little bit more. But I think the biggest thing was, changing the features. And I found that dropping the titles really improved this accuracy, despite the fact that it made all of the metrics above worse, like the cross-validation score and all of the other metrics that I evaluated on. But actually, when I submitted, the scores were a lot worse when I had the titles in, so I ended up dropping them, and it took me a while to figure that out. But not really sure why that is. I think maybe the test data looks different, or somehow the models were overfit based on the way that I assigned the titles. So anyways, that's my project, and thanks for listening.